So today we are going to be learning about completing the square. So in our last video, we looked at solving quadratic expressions by factorizing, and I just have an example here. So if we go through this example quickly, I'll show you how to do it from just the normal factorizing method. So if you have a quadratic expression like this, you have x squared plus 5x plus 6 is equal to 0. Then with a quadratic expression like this, all you need to do is find two numbers which can sum to make 5 and can times or multiply to make 6. Okay, so if you do that, then we know that it will be 3 and 2, because 3 plus 2, I just write here, 3 plus 2 is equal to 5, and 3 times 2 is equal to 6. So we know that our two numbers is 3 and 2. And then if we were to factorize that, it would be x plus 3, x plus 2. Okay? But we're not done yet, because this is equal to 0. This quadratic expression is equal to 0. So there is one more thing that we need to do. Very simple. If it's equal to 0, then we know that x plus 3 is either equal to 0, or we know that x plus 2 is equal to 0. We know that for our answer to be 0, one of these numbers need to equal 0, okay? So if we have x plus 3 is equal to 0, we know that x is equal to minus 3, and we have that x is equal to minus 2. So we know that for x squared plus 5x plus 6 is equal to 0, we know that our answers for that is that will be equal to 0 when x is minus 2 and x is minus 3, okay? So that's how we would do it normally. However, if I show you a different example now, okay, so right now I've got x squared plus 4x plus 5, and what completing the square is effectively you want to write it in this form, x plus p all squared plus q. So what is p? Well, p essentially is just b over 2. So when we look at a quadratic expression, okay, with a quadratic expression like this, it's always going to be in this form here, okay? It's always going to be in this form, ax squared plus bx plus c. So if p is b over 2, then we just look at the coefficient of our x term, and we just need to half it, just need to divide by 2. So in this situation, if we do this one, then we would have p would just be 2, because we would have a 4 divided by 2, and that would just give us 2. So our p in this instance would just be 2. So if we were to do that down here, let me use the green color now. So that would be x plus 2 all squared. Now, you've got to remember, when you have x plus 2 squared, that would give us a 4x, but it would also give us something else, right? It would also give us something else. It would give us a, if I just draw it out for you, it would give us a positive 4. But we don't want that positive 4. We just want just the x squared and just the 4x. So what we can do is, if we want just the 4x, or better still, what we can just do now is, if we just want the x squared plus the 4x, we can essentially bring that positive 4 to the other side. So it would be x plus 2 squared minus 4 is equal to x squared plus 4x. So now we have an expression for x squared plus 4x, and now what we can do is, now we can rewrite it in the form x plus p squared plus q. And if we do that, then we would have x plus 2 squared minus 4. And then don't forget, you need to plus the 5 because we haven't done anything to the 5. We've done nothing to the 5. We've just focused on the x squared plus 4x. We now need to include that 5. And then if you simplify that down, you'd have x plus 2 squared minus 4 plus 5 is just a positive 1. Hence, that we've written x squared plus 4x plus 5, we've written it in the form x plus p all squared plus q, where p is 2 and q would be positive 1. Okay. So what if we had something like this? We have x squared minus 8x plus 7 is equal to 0. So in this example, I'm gonna factorize it both ways. I'm gonna factorize it using the first factorization method we learnt, and I'm also gonna factorize it completing the square as well. I'm gonna do it both ways. You can see how it works and how you'd get the same answer. So with this one, we have x squared minus 8x plus 7. So if we do it the basic factorization method, then we find two numbers which can sum to make minus 8 and can multiply to make positive 7. So there are two numbers. Okay, those two numbers is it's minus 7 and it's minus 1. Okay, so therefore for our first one, we can just draw the bracket. So x minus 7, and then we have x minus 1. And what this means is that either x plus 7 has to equal 0 or x minus 1 has to equal 0. So therefore we'd have x minus 7 is equal to 0, or we would have x minus 1 equal to 0, which means that x is going to be a 7 or x is going to be a 1. So we know that when x is 1 and when x is 7, that expression will equal 0. So now that we've worked it out using the basic factorization method, now we're going to work it out by completing the square. And we should get the same answer at the end. We should hopefully get 1 and 7. So if we do that using the completing the square, then this is how it would go. So remember that with completing the square, we want to get it in the form, actually let me go back to the blue pen. We want to get it in the form x plus p squared plus q, okay? So if we do that with this, well, therefore we would have x minus 4. Remember that it's a minus 4 this time because we have a minus 8. It's a minus 8 divided by 2. So it'll be x minus 4 squared. Now, in this situation, if we were to expand the brackets, we would get x squared. If I just draw it for you, we would get x squared. We would get a minus 8x, which is all good, and we would get a positive 16. But remember, we only want the x squared minus 8x. We don't want that positive 16. That is a hindrance to us. We don't want it. We want to get rid of it. So as a result, we need to bring that minus 16 to the other side. So if we bring the minus 16 to the other side, then we get x minus 4 squared minus 16 is equal to x squared minus 8x. Okay? And so therefore, if we were to rewrite that, we would have x minus 4 squared minus 16, and remember there's still a positive 7, so we need to also include that positive 7, and we know that is equal to 0. So then we simplify this down a bit. So if I just scroll my page, if we simplify this down a bit, then we would have x minus 4 squared plus 9, no, not plus 9, minus 9 is equal to 0. And then from there, we now need to try and get the x by itself, okay? We want to make the x the subject of the formula. We need to get the x by itself. How do we do that? Well, it's very simple. We just need to, first things first, we bring that 9 to the other side. So we would get x minus 4 squared is equal to 9. And now we need to get rid of that squared, that to the power of 2. So how do we do that? Well, the opposite of something being raised to the power of 2 is just square root. So then we just need to, then that would be x minus 4, and that is equal to plus or minus the square root of 9. Remember that when we are square rooting something, it is not just going to be just the square root of 9. It's the plus or minus the square root of 9. The reason for that is because there are two ways we can get 9 from squaring a number. Okay, there are two ways we can get it, because minus 3 squared gives a positive 9, and also 3 squared gives a positive 9. Therefore, when we are going to square root something like this, we don't know whether that 9, we don't know whether that was it came from a minus 3 or a positive 3. We don't know that. Therefore, we got to remember that when we are square rooting, it's a plus or minus the square root of 3. That is key. So then after that, we just bring the 4 to the other side. So it would be x is equal to 4 plus or minus the square root of 9. Okay, and then if we work that out, we would have x is equal to 4 plus the square root of 9, and then that is 4 plus 3, which gives us the 7. But then we also can have x is equal to 4 minus the square root of 9, which would be 4 minus 3, which would give us the 1. So both ways will still give us x is equal to 1 and x is equal to 7. However, there could be an instance where you cannot use the basic factorization method to work these questions out. And that's what we'll go over in our next example now. Okay, so for this question, we have x squared minus 6x plus 1 is equal to 0. And for this question, we cannot use the basic factorization method, okay? There are no two numbers which can sum to make minus 6 and can multiply to make 1. So therefore, we can't use our normal method. We would have to use another method. So in this instance, we will complete the square, okay? We'll use completing the square. So for this one, again, remember that we want to write it in the form x plus p squared plus q. Okay, we want to write it in that kind of form. So for this question, okay, what do we do? Well, for that, we look at the coefficient of the x term, which is minus 6, and we half it. So we get x minus 3 squared, and then if we were to expand that out, we would get x squared minus 6x, which is good, that's what we want, but we'd also get a positive 9. We'll get that positive 9 as well. So therefore, we need to bring that 9 to the other side. So if we bring the 9 to the other side, we get x minus 3 squared minus 9 is equal to x squared minus 6x. Perfect, okay? That's what we want. So now if we rewrite this, x squared minus 6x, we can rewrite x squared minus 6x as x minus 3 squared minus 9. And then we just need to include the positive 1. So plus 1, and that is equal to 0. So then if we work this out, we get x minus 3 squared minus 8 is equal to 0. We bring the 8 to the other side, so we get x minus 3 squared is equal to 8. And if I just scroll down a little bit, then we can now square root both sides, okay? Get rid of that square, so we would get x minus 3 is equal to, remember, it's always going to be plus or minus the square root of 8. It's never just going to be plus, always plus or minus the square root of 8. And then lastly, we can just bring the 3 over. So we get x is equal to 3 plus or minus the square root of 8. Now, if you've done surd yet, then you can simplify down that the square root of 8. So it would be x is equal to 3 plus or minus 2 root 2. Okay, so we have two solutions here. The first solution is x is equal to 3 plus 2 root 2. Oh, sorry. We do that again, 2 root 2. And then we also have x is also can be 3 minus 2 root 2. Okay, so as you can see, these numbers aren't very nice, but that is the whole idea. If the number is not nice, then that's why you can't use the normal factorization method. You have to use something like completing the square or the quadratic formula, which is what our next video will be on. So if you cannot factorize the equation normally, then yes, you can use completing the square, which is what we've just learned. You can also use the quadratic formula, and we will go over that in our next lesson. So I hope you enjoyed this, and I will see you on the next video.